Okay, so everything we've been looking at so far has been leading up to solving equations involving sine, cosine, and tangent. So here what we're trying to do is we're trying to find angles. And remember that I keep saying that whenever you take an inverse trig function, you need to find the two solutions. So we've done a lot with sine, but remember that our ordered pairs, right, when we're dealing with points on a unit circle, our ordered pairs x comma y are in the form cosine theta, sine theta, right, because the radius is 1. Okay. So when we solve for things involving inverse cosine, we're going to look at x values. When we solve for things involving inverse sine, we're going to look at y values. Okay. And that, remember that tangent of theta is the slope of the line, or hypotenuse. Okay? So here's what's going on in part A. So basically we want to find all solutions between 0 and 360, and we're going to round to the nearest degree. And remember that our calculator is only going to give us one answer, and we as mathematicians need to find the other. Okay? Alright. And we also need to check, it's not going to come up in these problems here, but if our calculator gives us an answer that is negative, we first need to find the positive coterminal angle and then find the second angle. Okay? And we'll look at that one in class. But let's start out with this first one here. So we're trying to find x, where sine of x is equal to 0.7880. So we're looking for an angle whose sine is positive, right? And sine, or y values, are positive in quadrant 1 and quadrant 2. So we're looking for these two angles here, right, that have a height of 0.7880. So in order to figure out what x is, right, basically I take the inverse sine of both sides, and the inverse sine of 0.7880, according to my calculator, rounded to the nearest degree, is 52 degrees. Well, this right here is 52 degrees, but I know that that's not my only answer. My other answer is 180 minus 52 to get the obtuse one, right? So it's or 180 minus 52, and that's by looking at the picture, which is 128 degrees. So x is equal to 52 or 128, and I should put the little degree marks here. Okay. Now we haven't really looked at cosine and tangent yet, but let's do it now. Right, remember that cosine is an x value. So there's some angle that has an x value. That's 0.9205. So if I connect those to my circle, I am looking at this angle here and this angle here. So I have answers. These should be actually the same angles, the same magnitude angles. Okay. I have one in quadrant 3. Sorry. Let me erase this and start over. So let's take a look at cosine. Okay, remember that cosine is an x value. And so what I'm trying to find here in part B is I'm trying to find the angle whose cosine is 0.9205. And let me make this a little bit thinner so you can see a little bit better. So this is 0.9205 on the x-axis, right? And so I need to go out to my unit circle, and what I'm trying to do is I'm trying to find this angle here, right, measured from 0, because that angle has a cosine that is 0.9205, and also I'm going to have another angle here in quadrant 4 that also has that same trig ratio of 0.9205. Okay. So, what do? I first take the inverse cosine of both sides. So x is equal to inverse cosine of 0.9205. And my calculator tells me that that is 23 degrees. So, this little one here, in quadrant 1, that's 23 degrees. So what I need to do now is I need to find what this other one here, I'm just drawing an arrow, is in quadrant 4, and so that's going to come all the way around to here, and so that other one is 360 minus 23. And there are formulas for these, but you know, if you remember what these pictures look like, you don't have to memorize them, right? I just know that the magnitude of this little angle down here is 23 degrees. To get it, it's 360 minus 23 degrees, which is 337. Okay, so that means that my x is equal to 23 degrees or 337, and you can check your answer, because if you cosine both of them, you should get pretty close to 0.9205. Okay, so let's take a look at tangent. So tangent is a slope, and 8.1443 is pretty steep, right? So let's take a look. So what we're going to do is we're going to pretend that this line has a slope of 0.81443. So basically what I need to do is I need to find this angle here and this angle here. Okay, so the first thing that I'm going to do is I'm going to type this into my calculator, and the reason why we do that is because tangent is slope. So x is equal to inverse tangent of 8.1443, and my calculator tells me that that is 83 degrees. Okay, well, the distance from here to here, that angle is 83 degrees. How am I going to get the other one? Well, because vertical angles are congruent, right? We know that this angle here is congruent to this angle here. So measured from the x-axis, right, my other angle is going to be 180 degrees plus 83, which is 263. So x is equal to 83 degrees or 263 degrees. Okay. So here's what I want you to take away from this. Okay. Sine is a y value. Okay. So when you're solving for sine or taking inverse sine, you should have a picture like this. Cosine is an x value, and that's going to help you find your second angle, and tangent is slope. So whenever you take an inverse sine, inverse cosine, or inverse tangent, you need to find a second angle. And whether the book or I ask you or not, always draw a picture, because that will help you visualize what you should do. And I'm talking about these calculations. Let me highlight them. I'm talking about this calculation, and this calculation. Okay. Your book has plenty of formulas for that, which I'm not going to give you, and I certainly don't have memorized. Okay. What you want to do is to be able to look at the picture and be able to determine what kind of addition or subtraction you need to do. So spend some time with this. We are going to be solving equations for the remainder of the semester, and we're always looking for 2, sometimes more solutions.